In this video, we're going to talk about finding slope from a graph and review the concept of slope and what it means. So first of all, there are four basic kinds of slope. Positive slope, which looks like this. And the way that we know that it's positive is if we put an arrow on the right-hand side, we want to always think about slope from the left to the right, that is going up. And we generally think of up as positive. Negative slope, we put an arrow on the right again, and it's going down. So we call that a negative slope. This third one is neither going up or down if we put an arrow on the right. It's just flat. So that is a zero slope. And this line is so steep that we can't give it a name or a number. So we call that undefined. Those are the four basic kinds of slope. Finding slope from a graph line involves finding the rise or the amount it goes up or down. Rise is the amount it goes up or down, and dividing that by the amount it goes over. And slope is given the letter M in equations for lines. Why it's called M, we're not going to worry about. It just is. So we calculate M by finding the rise and dividing it by the run. Now we always want to start with the point on the left and move to the point on the right. Let me review that in the next slide. These are the steps for finding slope from a graph. We want to first find 2 points to work with. Let me pick a different color to draw with here. It's going to stand out a little bit more. You can see that in this graphic, 2 points have already been selected, this one and this one. Why were those 2 points selected? Because they go right, the line goes right through the intersection of the graph paper at those 2 points. We could have also picked this point right here. That would have been fine as well, because it also goes through that intersection. After that, we want to start with the left point. And if from that point, I'm going to use my arrow tool here and change my color once again. If we have to go up, we're going to call that a positive number. And we have to go up 1, 2, 3, 4 units here. That's why the number 4 was written here. We went up 4. Then we go across to get to that second point, and we have to go across 1, 2, 3, 4, 5, 6 units. So that's 6 across. So our rise in this case was 4, and it was a positive 4 because we went up, and our run was 6. So we set that up. The run will always be to the right if we start with the point on the left, and therefore it will always be a positive number. The number on top will be negative if we have to go down first, and that will give us a negative slope. Then the last step is that we want to reduce that fraction if we can to give us the best possible answer. 4 over 6 reduces to 2 over 3. So the slope of this line is 2/3. One thing I want to emphasize here is that it doesn't matter where this line is on our graph. As long as it has a similar angle to that, like that line or that line, it will have a slope of 2/3. It doesn't matter where it is shown on our graph. It's just a matter of how steep it is. All right. Let's move on to 4 problems that I've got set up, 2 on this sheet and 2 on the following sheet. We're going to find the slope of this line. So we want to pick 2 points that go right through the intersection of the graph paper. I'm going to pick that point and this point. Make those a little bit bigger. And now we just want to count. I'm going to change this to the orange color. We're going to start at the point on the left, and we have to go up to get to the point on the right, and we had to go up 1, 2, 3 units. Our rise is going to be 3. And then we need to find what we call the run, or the amount that we have to go over. That's just 1. So 3 over 1, and we reduce that fraction, and that's just the number 3. So the slope of this line is 3. A line with a slope of 3 will be very steep, and notice that it's going up as we go to the right. So it makes sense that that would be a positive slope. Okay, let me clear that off so we can focus on the problem to the right. So once again, we want to pick a couple of points. Let's pick this point and this point. Once again, I'm selecting those points because it goes through the intersection. And as long as you do that, it doesn't make any difference which points you select. We could have picked this point. That would work as well. We could pick this point. We could pick this point. So actually, I'm going to erase a few of those so that we're focused on, I'm going to work just between those 2 points. Now notice that now we have to go down to get over to the point on the right. And we had to go down 1 unit. We want to call that a -1. So our rise is going to be -1. And then we have to go over 2 units, 1, 2. So it's -1 over 2. We can try to reduce that fraction, but it can't be reduced. That's just -1/2. And that is the slope of that line, -1/2. All right, let's take a look at a couple more problems. Find the slope of this line. Now, this is a special case because this is a vertical line. And we could try to use this same approach, but there really isn't a point on the left or on the right. And we can see that this is a very steep line. So there's no need to do a calculation. We're just going to try to remember that this is undefined. We can't give that a number. It's so steep. That is an undefined slope. We don't need to do any calculation. Let's look at problem 4. Once again, we can see that this is kind of a special case. We do have a point on the left and a point on the right. We could pick lots of different points here. But we also notice that when we try to go up or down to go to this point on the right, we don't have to. That should be a reminder to us that this is a flat line. And therefore, we don't have to do any sort of calculation. A flat line has a slope of 0. And there really isn't a way to calculate this. We just have to remember that a perfectly horizontal line has a slope of 0, and a perfectly vertical line is undefined or has an undefined slope. Okay, that wraps up this video. Good luck with your practice.